Example 5 then of our work on friction. Let's take a wee look at this example. A block of mass 5.2 kilograms is placed on a rough plane inclined at alpha degrees to the horizontal, where sine alpha is 0.6. Now note that's just the same as 3/5, so it's going to be the same case, and mu is 0.4. The block is just prevented from slipping down the plane by a horizontal force P, and we're going to take G to be 10 in this case as opposed to 9.8. They always let you know if that's the case. We don't have a question. Oh, find P. We do. All right. So first of all, let's just get our wee angle sussed out. Because we know alpha is not, sine alpha is 0.6, that's sine alpha then is 3/5, so that's 3, and that's 5, and that's 4. So we know sine alpha is 3/5, which we can use, and we know cos alpha is 4/5. So we can use that information then for what we're looking for. Let's get our diagram drawn. This is an alpha. I think the pencil's about to go here, so we'll change pencils. Acting down this direction here, we have 5.2 kilograms. We of course have our normal reaction here. The block is just prevented from slipping down the plane by a horizontal force P. So it was going to slide down the plane, and there's two things holding it down. There's obviously friction, and then a horizontal force P, which is quite annoying, but that's okay, we can deal with that. And we have then that to deal with. Okay, so let's start resolving some stuff and see where we get to. We're going to go, sorry, it's an equilibrium. Alright, so everything going one way equals everything going the other. Let's go that way there. So we have R, now this is going to be fun, equals, so, that's a mistake, goodness, sorry, that's not 5.2 kilograms, it should be 5.2 G. I'm acting there, apologies. So we're going to have 5.2 G going this direction here is cos alpha. P is also acting down this way. Right, so what are we going to have? That's alpha. Can we now see, because of like the F rule, those are two parallel lines, so that has to be an alpha there. We're not resolving across the alpha, so it's not cos, so it's going to be sine. And we end up then with that. If we tidy this up slightly, R is 5.2 G upon 4/5 plus P upon 3/5. And tidy it up even further again. Our 5.2, remember we're doing 10 here, so that's 52 times 4/5, so that gives us 41.6 plus 0.6p. I'm going to call that equation 1. You can see where this is going, I hope. Going this way here, then what am I going to have? I'm going to have friction. Plus P cos alpha, because my P has been resolved this way here, equals 5.2 G sine alpha, resolving sine down the slope. 5.2 G, and let's tidy again. Also, are we happy? Let's change that actually so we can just have our two unknowns. This is friction, so friction is mu R. Friction is 0.4 R in this particular example, because in the question it tells us mu is 0.4. So I'm going to change this for a 0.4 R. P cos alpha, so that's 0.8p. 5.2 G times 3/5 then is going to give us 31.2. You put that in your calculator, and we have that. So we have two equations, two unknowns. There's a couple of different ways of solving these. and the numbers are slightly awkward, but because of the fact we know R equals, I'm going to do substitution. So I'm going to change my R here for a 41.6 plus 0.6p, and then try and solve then from there, and that'll get us our answer. So this is equation 2. I'm going to sub in 1. Naught 0.4 upon 41.6 plus 0.6p plus 0.8, p is 31.2. 0.4 times 41.6, I don't know what that is. 16.64. 0.6 times 0.4 gives me 0.24. P plus 0.8. P is 31.2. This is a slightly more complicated looking year 8 problem, but join together like terms, this one and this one. So I get 1.04p, and then take this over to this and take it away, and I get 14.56. And excitingly enough, we get P is 14 newtons.